Hi everyone, in today's lesson we're going to talk about how to solve rational inequalities. Now, inequalities are similar to rational equations. However, rational inequalities will have multiple answers and we must use a number line to find the values. So the first thing that we're going to do is write any inequality that we see with an equal sign and solve. So we're going to use this and we're going to change it to an equal sign. So I have 6 over x plus 2. And if I want, I can make it 2 over 1 equals 0. Now, I'm going to solve this rational inequality, rational equation, just like I would any other. My least common denominator will be x. So I'm going to multiply both sides of the equation by x. Or you could even multiply each piece by x if that's easier. So if you look, these x's will cancel. I'll be left with 6. Here I'll multiply the 2 and the x, and here I'll multiply x and 0 and get 0. And now I'm just going to solve for x. So subtract 6 on both sides, and I'll have 2x equals negative 6. Divide by 2, and x is equal to negative 3. Okay. So that's the first step. Now what we're going to do is we're going to place this answer on a number line with an open or closed circle depending on the original inequality. So because the original inequality has a greater than or equal to sign, we're going to use a closed circle. And then it says to find the undefined values and then put those on number lines with open circles. Now, undefined values always have to have open circles because they cannot equal it. So it can't equal 0, so it has to be an open circle. So let's actually switch those two steps and find the undefined values first. So the way that we find the undefined values, remember, is that we set the denominators equal to 0. So this denominator is an x. So I'm going to set that piece equal to 0. So undefined when x equals 0. So now remember, undefined values will always have open circles. And because this sign was a greater than or equal to, it's going to be a closed circle. So now we're going to make our number line, and we're going to put negative 3 and 0. Now, 0 is going to get an open circle, but negative 3 is going to get a closed. So negative 3 and then 0. All right? So now what we need to do is we need to figure out which way I'm going to shade. Am I going to shade this way, or this way, or a combination of any of the three? So the easiest way to do this, honestly, is to use the calculator. Now, this may be a little bit difficult for me to explain without the calculator being here, but I'm going to do the best I can. So what you're going to do is you're going to put this side of the equation into your y1. And then you're going to put this side of your equation into y2 in the calculator. So I'll even write it here. So for the y1 and for the y2. So for y2, we're going to put 0. And for y1, we're going to put 6 over x plus 2. So 6 over x plus 2. And then you're going to look at the table of values. So you'll have x, y1, and then y2. Now what you want to do is you want to find the values where y1 is greater than or equal to y2. So we're testing where this is greater than or equal to this, but we have to do it at specific x values. So we're going to choose a value that is greater than 0. Then we're going to choose a value that's between 0 and negative 3, and then we're going to choose a value less than negative 3. So I'm going to choose to test 1, negative 1, and negative 4. So in order, we're going to have when x is negative 4, when x is negative 1, and when x is 1. So what I need you to do now is put those in the calculator and tell me what these y1 and y2 values are for -1, 1, and -4. And then hit resume when you're ready. Okay, so when x is -4, y1 is 0.5 and y2 is 0. When x is -1, y1 is -4 and y2 is 0. And when x is 1, y is 8 and y2 is 0. So we're going to say, is 0.5 greater than or equal to 0? The answer is yes. This is a 0.5, not a negative. So yes, that works. Is -4 greater than or equal to 0? Definitely not. And the next part is 8 greater than or equal to 0? Absolutely. So the values and where it works is where you shade. So you see how that -4 works? So that means we're going to shade this way. And how the positive one worked, we're going to shade this way. So our answer is from -infinity to -3. So we write that like this, -infinity to -3, close bracket, union from 0 on. So 0 is an open circle, so it gets a parenthesis, 0 to infinity. So this is our answer. Okay, let's try another one. Okay, example number 2. So the first thing that we're going to do is write it with an equal sign. Okay, so I'm going to write this as x over 1 minus 10 over x minus 1 equals 4 over 1. Now, it looks as though the common denominator is x minus 1. So I'm going to multiply each piece by x minus 1. So starting off on the left-hand side, it's just x times x minus 1. These cancel. And then 4x minus 1. And now I'm just going to simplify by distributing the x into both. And I'm going to subtract the 4x and add the 4 to get it equal to 0. So x squared minus 5x minus 6 equals 0. And I'm going to factor. So x minus 6, x minus 1, plus 1. And my roots are 6 and -1. And we also have to check for my undefined values. So undefined when, how do we do that? Again, we need to set the denominator equal to 0. So the denominator is just x minus 1. So undefined, so set x minus 1 equal to 0. So undefined when x is equal to 1. So now we have a number line. Remember, undefined values are always open circles. And the values here depend on the original. So these two values depend on this sign. So because it's a less than symbol, we're going to make sure we use an open circle as well. So open circle because it's a less than, no line under it. So we have -1, which gets an open circle, +1, which gets an open circle, and then 6, which gets an open circle. So now I actually have to do 4 test values. 1, 2, 3, 4. So I'm going to test a value after 6, I don't know, let's say 10. Test a value between 1 and 6, let's say 3. A value in between -1 and 1, let's say 0. And a number less than -1, let's say 5. So again, we're going to take the left side of the equation and put this into y1. And then we're going to take the right side of the equation and put that into y2. So pause the video until you've done so. Now you want to make sure when you put this into y1 that you use alpha y equals for this fraction. If you didn't use alpha y equals, that's fine. You just need to make sure the denominator is in parentheses. Okay, so now I'm going to show you what my table of values looks like. So again, we need an x, a y1, and a y2. And we want to see if y1 is less than y2. So the x values in order are -5, 0, 3, and 10. These are the values that we're going to test. So when x is -5, my y1 is -10/3. And then I have y2 is 4. At 0, it's 10 and 4. At 3, it's -2 and 4. And at 10, it's 80/9 and 4. So the only ones that are less than are here and here. So that's where you'll shade. Okay, so I'm going to shade here. And here. So we have from -infinity to -1, union 1 to 6. All parentheses because none of them are closed circles. All right, let's take a look at the next page. Okay, so for these two, I'd like you to try them on your own and see how you do. Try first to set it equal to 0, solve, find the undefined values, and put them on the number line. So we're going to make number 3 homework and number 4 homework. Now I just want to make a comment about the undefined values. In number 4, you're going to set this equal to 0 and that equal to 0. So there will be 2 undefined values here. Okay? And then on this one, you're going to set just this piece equal to 0, and it'll be a fraction. So my undefined value will be a fraction, and that's okay. So I want you to try these two for homework, and I will go over them tomorrow in class. But I just want to see that effort has been made. If you're having trouble, that's fine. And we'll start the class like this tomorrow. Okay, have a good night.